So you want to make your environments a little bit more interactable, a little bit more alive. Today I'm going to show you what it is that I am doing in order to help create that. What I'm talking about specifically is when you are running through an environment, for example. As we move, you can see all of the grass and the mushrooms and everything that are reacting to the player as the player runs through the environment. And that just helps connect the player to the environment a little bit more. That's what we're working on today. I'm going to be showing you how I broke that all down as we go. What's up, everybody? My name is Kevin. Welcome back to another dev stream. These are basically a look behind the curtain, a little bit about the making of the game. I tried to take these dev streams and make them a little bit more tutorial-like, and hopefully you can take some of the learnings and apply some of the methods and stuff like that to your own workflows and things like that. This is an open conversation. This is a dev stream. You will hear members of our community. This is part of our Patreon community. They hop in, help me out, keep me sane. Very much appreciate our Patreon community for all this. So you'll hear comments, you'll hear questions, etc. as we go through this. I think I mentioned my name is Kevin, but if not, it is. And here we go. Let's get going. So to start with, this is all going to be done with materials. So that entire effect that you saw was built using material effects. And what we're going to do is I do need to do a little bit of a reset here on a couple of things so that we can set it up from scratch. And I'm going to walk you through all of the things that are happening. So let me go ahead and grab our player and get rid of a few things so we can get back to defaults. So we're going to get rid of the tick. And then we're going to go back. And just to show you a little bit about how this is set up, let's get rid of some of these planes so that we can actually click and you can see some of this trickery. Okay, so what we have here is we have all the assets that you're seeing here. None of them are 3D. These are all 2D cards. So as we pan around, you can see this is all 2D tricks. So how do we make these mushrooms, this blade of grass, etc., all feel like they're moving when the player walks by without using overlaps for every single object? That was the goal. I was trying to find a way to do this performantly without doing that for every single object. So let's go back and edit a couple more things and reset our stuff so that we've got what we're looking for here. Okay, so now that we've done that, if we press play now, and we go back to full screen, you'll notice that our mushrooms, grass, none of it moves anymore. So what we're starting with is we're starting from scratch. So here's the theory. This is the theory of what it was that I was trying to set up. Each of these is actually a plane. And if we look at the blueprint for this and we look in the viewport, in this particular case, it's a tree. But in actuality, what it is it's a square plane. There's only 4 points on this plane. And if I bring up, I'm going to bring up Photoshop real quick so I can draw you all the theory behind this. Basically, what my thinking is that if we can just shimmy the top 2 vertices, it'll make it look like it's moving. There's lots of WPO tricks that happen. Hold on, let's just go ahead and create a 1024 create. Where'd it go? Here we go. All right, now we can draw. So we've got this plane, right? And the things that are important to understand are, this is the U direction. And in vertex space, in UV space, this is the same thing as, you can think of this like X, sort of, okay? And this is the V direction. And you can think of that a little bit like Y. But remember, this is in the space of U's and V's. But anyways, the point is, this is our plane, and on our plane is our blades of grass. This is our blades of grass. So what I want to do is I want to take this point here and this point here, and I want to shimmy them like this. And I want them to go basically left and right, just like that. All right, so that's the theory behind what we're trying to do. So we're going to walk through this step by step and build it out. Now, I know this works because I've already built it out once, but we're still going to stumble through it together because I think the learnings on how we get there are helpful, especially if you're new to materials and all these kinds of things. I am going to bring up my reference material. I'm going to keep it over here just so hopefully we don't get too lost in the weeds today. Just so you know what we're going to end up with. Actually, this is probably cool to show you all. It's going to look like a lot, but it's not. Everything down here, this is what we're setting up today. And we're going to do it in an hour. It's going to be fine. I'm sure it'll be fine. Okay. So here we go. So first things first. We need to take a look at our material. We have this environment depth fall off, and let's open that up because this is where we're going to be working. And right now we have nothing connected to our world position offset. Okay. So here's what I want to do. Let's just make it move. Let's start with making it move. So if we get time, and then we connect that to a sine wave, what this is this is a sine wave. A sine wave, for those of you that are rusty on our math, it's a wave that looks like this, roughly speaking, right? This is x, this is y. Okay, this is important to understand because we can use this to drive the position. So this is basically going to be a back and forth, 0 to -1, or a 1 to -1 effectively is what's happening. Now, if we just plug this straight into our world position offset, all kinds of bonkersness happens. Hold on a second. World, did I connect that in? Yeah, I connected that in. Sine, world position offset, apply. And if we look at our visual base, you can see our whole tree is moving. Okay, it's not moving the right way though, but it is moving. So, and effectively what's happening is you can see how it's pulsing. That's what that sine wave is doing. And what is happening is each of the vertices of this plane is being shifted in space, but it's moving in the wrong direction. It's just moving, I think it might be, I don't even know, but we need to tell it exactly which direction. So here's what we're going to do. We're going to take the vertex normal in world space, and we're going to multiply it by this. Okay. Now what's going to happen is this is going to make this move in the direction of the vertex normal. So now we still have our pulsing, but you'll notice that it's perfectly front to back. Now, that's not going to work for us because remember, our game is 2D and it uses cards. And all of these things, by the way, they apply in 3D as well. You can move all of the vertices of a 3D object the exact same way. All right. So in this particular case, we're going front to back. So we don't really want that. So what I want to do is I want to take this material or this normal that we're using, and I want to rotate it 90 degrees. So let's rotate this, rotate vector 90. Now there's a bunch of options. This is a material function. I did not write this function. It was just in here. I think it might be standard. If it's not, fill out the comments and I'll drop a code sample of it. Okay. But what I'm doing is I'm rotating these normals 90 degrees in Z, which is like this in world space, so that it will go side to side instead of front to back. That's all we've done here. Okay, and if we go back to our object, you can see our tree is now shifting side to side. This is cool. Here's the crazy thing. If we go into our level right now, the whole thing is shifting side to side. Every asset in the environment right now uses this. So we're going to need to fix that. Okay, the other thing is we don't want the whole object to shift. We want just the top of the object to shift in this case. So these should be triggering a couple of things in our material minds. So one, we need a filter of some kind, a checkbox that will allow us to turn this off for everything and only on for the things we want. That's one thing we need. Second thing is we need a way to mask this effect. And we need to mask it so it only affects the top 2 vertices. So let's start with the mask. Also, I'm noticing that our grass must be using the wrong material because it is not moving and it should be. So that's part of our reset. Yeah, it's not using the right one. So let's get this to, this is, what's the material called? Depth Falloff? Depth Falloff. Oh, it's this one here. We can just use this one. There we go. So now our grass moves. I think I accidentally updated these in the scene, which is why we just need to fill this in. So now our grass moves. All our mushrooms are moving. One more blade of grass. I think I did this as an override before I realized. Okay. Okay, so everything's moving the same. Great. So now let's go back to our fall off. Next step, let's start with masking the effect. So it only gets applied to the top 2 verts. How are we going to do that? There's actually a lot of different ways to do this. We could make a mask, which is a texture we import. We're not going to do that. We could use a linear gradient. So let me just show you here. If we create a linear gradient and we preview this, start previewing node, you can see it has black on the left and white on the right. That is effectively a mask, okay, which is great. So that we could use that, but we're not gonna use that. We are going to use just the texture coordinates because the texture coordinates can do this too. So if we take the texture coordinates and we mask this to be just the U value. Now this is going to be labeled incorrectly in the mask. So RGB, you gotta, this is why I said you can think of U and V as X and Y, but you can also think of it as R and G and an RGB. You just gotta understand it's the 0, 1, and 2 slots of this. So this R value is actually the U value. So if we just start previewing this node by right clicking, you can see we're left to right. Now I don't think I want the R value. I think I want the G value. There we go. So now we have a mask where the top is black. So that means it doesn't get any effect and the bottom does. If we were to connect this in, this would actually break us. And what I mean by that is, well, no, it wouldn't break us. What would happen is we'd have the opposite of what we want. If we multiply this in, and we stop previewing, and we apply this, when we go back to the world, you'll notice that the bottoms of the meshes are moving. This is the opposite of what we want. So this is where we go, and what we're going to do is we're going to take this and we're going to go 1 minus, 1 minus. So this is going to flip that around. So apply that. We can go back to our I don't know, our environment card, if you will. And you'll notice that the top of our tree is moving. It's pretty cool. So that part of it already working. Now, we don't want everything to move, so let's go ahead and set up our blend, if you will. So here's what we're going to do. We're going to add a parameter that allows us to turn this off per asset that we place. So let's put another multiply in here. We're going to connect that in. And I'm going to explain why I'm doing this. We're going to effectively do this as an alpha blend, but it's really just a simple mult. So let's just promote this to a parameter. And we're going to call this React to Player Alpha. And we're going to default it to 0. Okay? Now, once we do that, this no longer shakes. It stops shaking. Now, this stops shaking because we need, and I believe it's in our construction script, and I've already got this filled in. So here's what's happening. The way this actor works is when it starts, it goes through and it actually, you can choose which of the many different environment assets. In this particular case, there's an array of textures you can choose from. So you can choose, like the grass one has 10 different grass and 4 different mushrooms or whatever it is. So all of this is about setting up which material is actually shown. And all I've done is at the end, I've added this react to alpha at the end. It defaults to 0. We're setting it there. What this does is this makes it so that when we look at our environment now, it's not most of it is not shaking, like the bricks and everything. But because I had run through this before, we actually do have a react to alpha over here. I'll make this a little smaller. And let's bring this up a little. Okay, see this react to alpha? If we set this to 0 for the grass, oh, not negative. Let's go 0. You can see the grass stops moving. So by default, all of these bricks, everything, none of them are moving. Now I went through and I picked all of these items, like the mushrooms and everything like that, and I set them to react to alpha. Okay, so if we play now, our environment, you can see it's moving. It's a little bit hard to read, so let's exaggerate it, okay? So we're going to exaggerate this effect a little bit, and just to make it a little more readable so we can see the effect of our stuff. And there's a couple different ways we could do that. I'm going to, like, for example, we could actually use this alpha as a multiple, but I'm not going to do that because I want to be able to take it out later. So let's just stick another multiply in here. And this one, let's try something like 60 and apply that. And when we go back to our environment, yep, that is totally moving. It is very clear that that is moving, right? Okay, so everything's moving. We've gotten through a pretty good chunk of how this works. Now comes the tricky part. And the tricky part is we don't want this to move unless the player passes by it. Otherwise, it's just wind, which is also a cool thing that we could use this for, to do wind. However, in this level, in these swamplands, there's no wind. It's a very, like, not even a cool breeze. The mist just drifts. So we don't really want wind right now. So what we need to do is we need to find a way to only move if the player has run past the object. Okay, so this is where stuff starts to get fun. Okay, so in order to do that, we need a couple things, all right? We need to know the player position, and we need to know the velocity the character is moving in. And we need to get that into the material. So to do that, what we're going to do is we're going to set up a material parameter collection. Okay, and in this particular case, what we've done, the way this works, is this is, you can create these. If we go back here, we can right click, and I believe it's under, actually, material parameter collection. Here you go. This is how you create it. You just pick this, and then this is a new material parameter collection. When you open it, it's empty, and you would just add scalar parameters, vector parameters, etc. Now in this particular case, I have defined a new material parameter collection. For some reason that's not closing. Oh, I see what happens. I undocked this. There we go. Okay, so I've set up a new one. We don't need this one. Let's delete that. And what I've done is I've created two variables in here, player location and player velocity. They are both vectors. Now, the point of the material parameter collection, what it is you can think of it as variables that are global to all materials. So every material could have access to this. So in this particular case, I might even just call this environment for material parameter collection, because maybe we'll add wind and stuff. We may rename it later. But for now, I've added two variables, player location and player velocity. So now what we need to do is we need to stumble through a little bit of setting these. So to set these, what we're going to do is we're going to add in our tick. Add event. Tick. Okay, and then we are going to call the parent function just in case. And all this is getting it set up so that our materials can get the player location. okay? And then let's material parameter collection. Nope, that's not it. Set material parameter collection. Oh, I forget where it is. Give me a second. Material. It's hidden in a, it's not actually a, it's actually a, there's an actual thing that you can do. MPC. I know what I'm looking for. You just have to pick it, and you pick what you want. Set material parameter. Here we go. So set material, so set vector parameter value, and you got to tell it which collection. In this case, we're using the environment reaction, and then the parameter name will just show up here. So we're going to use player location, and what we're going to do is we are going to okay, that's going to be another thing later. Okay, so let's get the actor location. Actor location, and we're going to feed that into the location. Pretty straightforward. Okay, and then we're going to do this again, and what we're going to do on this one is we are going to get the actor velocity from our character movement. So let's get the velocity, and we'll plug that in here, and that's going to go into our velocity. Okay, so now once we have these, we can now use these inside of our materials. So let's compile and save that. All right, that doesn't actually do anything yet other than make it available inside of this material. So now we got to start the work of how do we make it so that the materials actually move when they're supposed to, move in the right direction, and all that kind of stuff. So here's what we're going to do. Let's make it so that, I think what we'll do is we'll make it so that it only moves if the player goes past the object first. Okay, to do that, what we need to do is we need to get material parameter collection parameter. Here we go. Is this what I want? Nope, that's not what I want. MPC, nope. Material parameter. That's not it either. I just want a collection here. Collection parameter. Here we go. There we go. And then this is our environment reaction. And then in here, we're going to take our player velocity. Okay, so this is our player velocity. And we're also going to need our player location as well. So let's just copy this and change this to our player location. So we're going to need both of these. So what we're going to do is we are going to, let me take a step back here for a second. One of the ways that we have done this in the past, and what is often done in here, is when you want something to move in a material, or you want a hit flash to play, or any of those things, what we've done is we've said this is the start time. Then we get the game time in seconds, and we subtract that off, and then we use that start time and the game time in seconds to actually to scale out the effect. However, that would mean for every single actor that we've placed, all of our environment cards, we would need to do some kind of detection of collision to see if the character is overlapping it. That's insane. That's an insane amount of overlaps. We can't do that and be performant. That's why we're doing this one different. We're doing this one in a we're not going to use time in the sense of the way we've done this in the past. So what we're going to do is we are going to take this player velocity, we're going to normalize it. And then what this is going to do is this is just going to give us a little bit of a direction. 0 to 1. You all still here?
Oh yeah.
Okay, cool.
Indeed we are.
Cool. So we're going to normalize that. And then what we want to do is, this is our player location, but we need to know the absolute world location of the vector, of the vertex. So if we get the world position, if I could click, I'm having a hard time clicking today. All right, we take the XYZ value and we subtract the XYZ value. We need to mask this because this has 4 values for some reason. If we mask this to XYZ, which is RGB, remember it maps to RGB, okay? And we subtract these two, this gives us a vector. And it gives us the vector from the vertex to the player. And then what we can do is we can normalize that so that we have, we're comparing 2 vectors that are normalized. And then we can use the dot product to figure out the direction. Because remember, based on our dot products, if it's negative, it's one way. If it's 0, it's I think it's indeterminate. And if it's 1, it's etc. So if we use a dot product here, this gives us effectively a direction. And then what we can do is saturate that to make sure we don't go beyond 1. All right, and then subtract. Okay, then what we're going to do is we're going to, so now we have a value that goes to 0 to 1, but we need to flip it. We're going to go 1 to 0, so let's subtract, and flip this to be 1 minus. So this is effectively 1 minus this value. And then what we're going to do is we're going to multiply our effect by that. So we have our alpha, we have all this stuff. Let's back some of the, we need to make some room here. We're going to need a lot more room because you saw how big that graph was going to get. Okay, so we can keep this up here as our enable. And then let's take and create another multiply. Control drag this pin so I don't have to go hunting for it. Multiply this end. Now I think, I could be wrong, I think this will make it so that it only, actually no, it's, let's see what happens here. We may need to do a little bit more work here. Okay, so it's only part of it. It's, oh, I started the encounter on accident. What's happening is it's stopping the movement when we go the other way. So we need a little bit more work here. So, and the work that we need is we need a little bit of a fall off to this. Okay, so this kind of gives us the directionality of it. Now we need, we're going to need a fall off. And part of the problem is right now we're always moving. So where's our sine wave? This thing right here, we're going to need to replace this whole thing because eventually we're going to get to a point where it will move, and we're going to keep it because I want you all to see them. It's not a mistake. I want you all to see the learnings that are going to happen with that. But basically, we're going to end up replacing the sine wave because of some stuff I'm going to explain in a minute. But we do need to change when the movement happens. We only want the movement to happen when we're close to the object that we're passing. So to do that, let's do this. Let's get our actor position in world space, and let's get our player location. Okay, and what we're going to do is we're going to subtract these two to get a vector again. And then we're going to get the length of this. And then what we're going to do with this length is we're going to have an inner and an outer radius. And we're going to say if you're, between, let's say 100 and 400, the object will only move if the player is within 100 or 400 units of it, and there's going to be a fall off to it. So we need 2 radiuses. We need an inner radius and an outer radius, where in the inner radius it's at 100%, and the outer radius it's at 0. So what we're going to do is we're going to subtract, And what we're subtracting is our inner radius. So let's promote this to a variable. And we're going to call this our ENV react inner radius. Okay. And let's default that to 100 to start with. Okay. Then what we need to do is we need to phase it out as we get further away. And we're going to phase it out by the distance from the inner radius to the outer radius and divide by that. So let's go. So we're going to eventually divide by our fade out. So our fade out is going to be we have our inner radius. We need another subtract. We need our outer radius. So let's make our outer radius here. Promote to variable. This is going to be our ENV react outer radius. Whoa, I may need to start wearing my glasses during these things. Okay, so we subtracted and then we're dividing by that. And that gives us our fall off. This is effectively like our distance fall off. Okay, and then what we want to do is let's saturate that, which basically remaps it to 0 to 1 just in case it goes beyond that. And then we need to flip it again. So we're going to do the same 1 minus thing, the subtract that we were doing over here. So we're going to subtract that out, and then we're going to multiply that in. So this is going to go into another multiply up here for us. So let's just do this. Control drag so I don't have to go find that. Drop this in. And theoretically, what should happen now, ooh, we got an error on our subtract. Oh, I forgot to mask this. Because, okay, so look at this error. Actually, you probably can't see it because I made this small. We've got invalid type vector 3 with a float 4. So for some reason, this player location is a float 4. I'm terribly confused how player location is a float, but whatever. Component, mask. So we only want XYZ, which remember is RGB. And this is going to plug in here. All right, so let's apply that and save. Oh, dude, we have not saved in a while. So let's save this. Now, theoretically, I think those are the pieces that we need. Yeah, okay, so as we get further away, see how they're not moving? If I'm far away, depending on the direction. So we've got the fall off kind of working in there. All right, now we need a few more things. We have our reactive player alpha. I wonder, no, that shouldn't matter. Okay, so that gives us our position. We have our texture coordinate mask. Now, we want to do, there's kind of really no way around it at this point. We have a problem which is caused by our sine wave here. And the problem is this sine wave is always going. It's always moving. And what we really want is we want this to only happen if the player triggers it all. And we also need it to be in time correct. So here, let me make a new layer here and show you what I'm talking about, the problems that come with this. Why is it blue? Okay, so let me show you the problem. Okay, so when we're looking at a sine wave, okay, it goes like this. Always, forever, right? Now imagine this is game time. This is 0 seconds. Okay, if our player is running and we pass the flowers at this point, it is going to, let's say we're running to the right, okay? It's going to push the flowers to the right because they go negative, because sine is negative. So we're multiplying by negative numbers all the way, we're down here. But let's say we're still running and we pass another flower at this point. Well, we're going to be multiplying by positive numbers here. These are all positive numbers over here, okay? What we really need is, what we want is, we really want a sine wave that starts right when we want it to. And we want it to be positive for right to left and negative for left to right, for example. Okay, now what it actually isn't important. We just know that we need it to be set. We can't get what we want with a sine wave. So the idea that I had was we're going to make our own sine wave, and we're going to do that with a gradient. So what we're going to do is we're going to create a curve, linear, and an atlas that will let us, basically, if you think about it, imagine a gradient. So this is a gradient, okay? It goes 1 to 0, okay? And then let's do another oops. And then let's just say, actually, Control D, G. I see. Nope. Somehow I got that. Oh, God, what is happening, Photoshop? You're not helping me. Rectangular. Home. There we go. So we go 1 to 0. What we want is we want another gradient that goes 1 to 0 again. Okay, but we actually want it to be smooth on the way in and out, so right? So we want that. If we make a new layer, that, take this, G, G, G.
I think I missed a step. You're just trying to oscillate between 0 and 1 instead of
Correct.
1 and -1?
No. I am trying to, well, okay, so what we're doing is we're replacing, okay, hold on a second. What we're doing is we're solving this problem. We're solving the problem where time is always running and the sine wave is always running. So at any point when we go to start moving the environment objects, we don't know if we're going to be on the positive side of the sine wave or the negative side of the sine wave, because we can't control the start and stop of the time. We don't know when the player is going to run past the flower. And because we can't shift, because we don't have an actual start time, because we don't want to track the overlap with every flower, we need a known way to trigger this effect without using time. So what we're going to do is we're going to create our own sine wave using gradients like this. So this goes 0 to 1, back to 0 to 1, back to 0. And we're going to multiply that in based on the distance. So what I mean by that is if we add one more thing, so we have, this is, imagine, okay, so imagine, let's see here, what's the best way to explain this? Okay, so here's our blade of grass. Okay, this is our player. Okay, this distance is 400. Okay, now at this point, now imagine the player is running this way. It's okay. So at this point, we want our value to be 0. And if we, what we really want, if we were to map this, we want a sine that goes like this. Okay, so we get this nice fall off. So what we're going to do is, these is not time and sine. What this is color. So what we have is we have a gradient, and our colors are going to start at, it's going to be, let's say, black here, and it's going to slowly get towards white, which is really hard to do when you're using black and white colors. So I should probably use a different color, but let's just stick with it. But basically there's a gradient that goes from 0 to, of course, I am gonna use a different color. So we're gonna go from here to here. This is basically 0 to 1, right? And then we're gonna come from 1 back to 0 here. And what this is gonna be represented by is a color, right? Black to white to black to negative white to, or negative black actually, which is why when we get into material space. So there's two ways to think about this. Yet another drawing. Okay, so what do I mean? I don't know. Let's see here. when we have a sine wave, let's just say that our sine wave is going, and we want to go from 0 to 1 to -1 to 1 to -1, right? The problem is if you're dealing with color, normally you can't do that. So what we could do, is we could, let's say that this is 0, this is 1, and this is 2. What we can do is we can define our sine wave up here, right? And the way we do that is, sorry, my drawing's so awesome. And then what we can do is we can take the whole sine wave and shift it down by subtracting this number, 1. And that will effectively recenter it to be here. Okay? Now, we can do this in materials because a material value the red value can go beyond 1. It can go to 2. It can go to 1,000. That's why we saturate. This little saturate node that we use over here, this is largely because we want to make sure when we're subtracting numbers and vectors, what this does is it clamps it back down to be between 0 and 1. Okay, so what we're going to do is we're going to build a gradient. And the gradient we're going to build is, we're going to do it using a curve. So let's create a new curve. And it's going to be, when we do the curve, this is important, you can choose the type of curve. So we're going to choose a curve linear color and select that. We'll call this CLC tutorial environment sway. All right, and what we're going to do is in this environment sway, what we've got is we've got a curve. And we're just going to sculpt the sine wave that we want. Instead of using time and instead of using the actual sine wave, we're going to use this curve to define our own. So let's start doing that. So if we take these values, we could probably zero all this stuff out. So let's go here, and we're only going to use the red channel in the end. So we can unpin all this other stuff. We can take the red channel, we can start at 0. Actually, let's do what I said we were going to do. And this value is going to go up to 2. And then let's middle click to drop in a few others. We're going to come down to this, and then we're going to come up. And then let's go down one more. So we're building a curve here. This is just our sine wave curve. And what we want to do is, let's get this to 2. And we'll take this down to, probably don't need to go all the way to 0, but we can. And then 1.5 and 1. So this is centered around 1 is the overall point. Now let's take all of these and make them smooth. I'm doing that. You can either right click these and choose auto. If you pick a point and right click, you can choose auto tangent, or you can just pick it and press the 1 key. Okay, so this is our curve now. And in order to be able to use this, all we have to do is, I want to make sure this doesn't go below 0 though, actually. I may move this up slightly. So now in order to use this, all we need to do is get access to it in the material. To do that, we have to create what's called a curve atlas. So, and to do that, let's do an atlas. I think it's atlas, curve atlas. So this is going to be our curve atlas environment sway tutorial. Okay, and inside of our curve atlas environment sway tut, what we do is we add in a gradient curve over here. And that is going to be our ENV sway for the tut. Okay, so now we have access to this. So all we've done, the biggest point here is, the goal here was just, we're making our own curve to drive this, and we're using colors to do it. So if we save all of this, we go back to our depth. We're going to replace this time and sine wave with our curve atlas. So let's go ahead and do that. So let's get a curve atlas row parameter. Okay, and this is going to be our environment sway atlas. Okay, and in here, we're going to take the curve. The atlas we need to set first. So here's our sway tutorial. And then in here, you'll see our curve now shows up. So what this is going to do is this is going to give me the RGB values that I want. Okay, so if I sample this, I can get what effectively I'm going to be getting is I'm going to be getting these values, 2 to 1 to etc. Okay, and what we're going to do here is we're going to take this and I'm going to subtract 1. I'm going to subtract 1, and the reason I'm subtracting 1 is exactly what I explained. We want to take this curve and recenter it to be around 0, so it has positive and negative numbers. Now, if you're thinking, why not just define the curve to go from 1 to -1 back to 1 and so on, you can do that as well. Originally, when I set up this, for some reason I forgot you can go negative black as well. So you may not, you probably don't need that. If we get time at the end, we can go back and fix that and take that out. But this is why I'm teaching you the understanding of this all. So this is our curve, and what I'm going to do is I'm going to move this magnitude, this extra multiply that we have, this 60. I'm going to move this over here now. I'm going to move this to multiply by our curve because this is going to be our amplitude effectively. And then we need to take and we need to do a little bit of, we need to sample. Now we need to drive all this. Hold on a second. Let me make sure I've got this all straight. Subtract, multiply. 2 adds their velocity. Cool. Let's connect that into, yeah. All right, I'm just going to shift these around and multiply a little bit. I'm going to take that multiply and let's connect this in. Okay, and we're going to connect this one into here. Actually, we'll disconnect that for a second. And we're going to reconnect in. We're going to get rid of the sine. Okay, and we're going to take this and we're going to connect this into here. Okay, this is not going to work yet. All right, what we're doing is this really just changes. This hasn't changed anything other than, you know, our texture coordinates are getting multiplied in. Okay, but in a minute we're going to come back and we're going to use direction a little bit. But the big thing is about why this isn't working yet or going to work yet is because we don't have a curve time. We need to get a curve time, but remember, we're not using time. We can't use time. We're going to use the distance instead. We're going to use the distance from the object as our time, and we're going to remap that to be 0 to 1 or whatever we want. So how are we going to do that? Let's get the actor position world space. Okay, and we're going to get our player location. Actually, we can just copy this. This is exactly what we want. Okay, this gives us plus a length. This gives us our distance to the player. Okay, and then with that, we're going to subtract the inner radius. So where's our inner radius? We need both of these actually. We're going to subtract the inner radius. Okay, and then what we're going to do is we're going to divide by the outer radius minus the inner radius. So effectively what this is going to do is it is going to remap the distance. Let's just say that you're standing at 400 units from the piece of grass. We know our inner radius is 100, so it's going to subtract 400 minus 100, which is 300, and then it's going to divide by 300. Also, our outer radius does not have a default value yet, which is part of the problem. We need this to be 400, I think. Actually, let's go 500. Okay, so then we subtract it and we divide that. So 500 minus 100 is 400. If we're standing at the 500 point, 400 units, 400, that's 1. You basically divide it out and you get 0 to 1 effectively. Okay? Cool. So then we divide and then we feed this into our curve time. I don't know if this is going to make sense yet. when we look at it in editor, but let's just see. Yeah, look at that. Okay, so stuff is moving just by doing that. And what's happening, now we've got a couple problems here, okay? So, but let's celebrate. 10 minutes to go, and we at least have stuff moving, which is cool. Okay, so the problem is, you'll notice that if I come in here and I sit and I stop, all of a sudden the mushrooms pop. Okay? They're just kind of like popping. But you can see they're shifting based on our distance. So there's just a couple of like quality of life things that will help with this so that they don't pop. Okay, also the speed of the settle is pretty fast. So there's a couple things we're going to make some changes to here. First off, I'm going to add in one more divide in here just to slow it down. What this does is it basically it makes the distance twice as much to get the same effect. Okay? Now, what we actually need though is we need one more. We only want this to happen when the player has just passed the piece of grass. So what we're going to do is we're going to put in another multiply in here where we're going to basically create a, it's almost like an alpha. Okay, so let's take this, connect this in, and let's build our alpha so that it only happens after the player's, when the player is moving. So we need our player velocity. Do we have it? We don't even have player velocity yet. That's the whole reason we got player velocity. So let's take this, copy that, change this to player velocity. So we only want this to happen when it's moving. We're going to mask this because we only need, because we're using, and this is going to be different depending on your project. In our case, because we're using a 2D platformer, we're only moving left to right, we only need the X value. All right. And then from that, I'm going to get the sine. What does this do? So this gives us whether or not it's negative or positive. That's it. That's all it does. Okay, and we're going to multiply that by the player velocity again, but the magnitude of it. So let's get the length of this. The length of this. And what we're going to do is we're going to multiply it based on how fast our character can move. So if the character could move 200 units max, or whatever that value is, when they're at full speed, we want the full effect. If the character is not moving, we basically want it no effect. We want it to mute out. So in that case, what we're going to do is we're going to take the length and we're going to divide this by, in our case, for us, if you go and look at our character movement component, it should be about 200. So velocity, speed actually is I think what I'm looking for, speed. So we have a max walk speed and a crouched of 300, swim speed. Let's try value of 200. I'm gonna try value of 200. Divide by 200. Okay, and then we're gonna saturate this just so that we're 0 to 1. Okay, and then we're gonna multiply. We already have our multiply here, and then that's gonna control. And this is effectively going this whole section. If we comment, this is the speed-based alpha, if you will. Okay, this whole section here, if we were to comment this, this is our sine wave, not our sine wave, this is our fall-off curve, if you will. Okay, so now, velocity, what are we missing? Are we missing anything? I think that might be it, you all. Let's check it. Apply, save, press play. Look at that. See how it softens? Oh no, there's one other thing. There's one other thing. Actually, this looks pretty good. Okay, I'm going to show you one last thing just in case. There is a world, and I'm not sure why it's not happening right now, but when you came in here and if you stopped, what happens is you might see a pop in your grass and your mushrooms. And the reason being is because your velocity goes from 900 to 0. And so what happens is when it goes to look up where in this curve 900 to 0 is, it basically just pops. So a way to fix that is rather than passing in the velocity, we v-interp to the velocity instead over a period of time. And that is a way to smooth that out. So I'll show you that real quick just to do that. And so what we're going to do is we are going to set our vector parameter value, smooth velocity. Effectively, oh, do I already have the variable defined? I probably already have it defined. I do already have it defined. Okay, that's just left over. So I created this variable called smooth velocity. We get that. Let's do a v-interp to. Okay, and the target is our velocity. The current is our smooth velocity. Okay, and the delta time is going to come from delta. And the interp speed, what did I use before that was good? Let's try 10. Okay, and that is going to feed into here. And then I think we need to set this to, I do think we need to set the smooth velocity. Hold on. Interp 2. Let's just try that. I feel like we might need to set that. Just double check. I think that's good. It's working. However, our smooth velocity doesn't ever get set, so I think we need to set this. After we send it, we're going to set our smooth velocity to the new value, I believe. Let's try that. See if that breaks everything for fun. It's funny, I actually kind of like the effect better without it. So at this point, you get to do what you want to do with your stuff. If we just connect velocity back in and this looks good, we may not even use the v-interp 2, but I did want to show you that there just in case, just from the precedent of, yeah, I like it without it better actually. Okay, so, but it's still a good reminder where rather than, the problem is if you wanted to smooth this out in the material, it would be very difficult. Don't do that. Just pass in a smoothed out value instead. Okay, so this is kind of wild, y'all. Like one last look at where we ended up. And this now works for anything in the level. So if I wanted a tree to move, I could put a tree in here. And the other cool thing about this is, let's just take this, and let's duplicate this blade of grass. And what I can do when I duplicate this blade of grass is, right now our reactive player alpha is set to 1. I could make it 10. And what's going to happen is when I walk by this blade of grass, that second blade of grass is going to move a lot, like so much. Boom, it like moves way too much. So let's knock that back. Let's try double. See, it moves a lot more than the other ones. And what I've done here is, if we go through and we look at this, I don't want this blade of grass in here anymore. If we look at this, some of these smaller mushrooms, they have an alpha of That one's 1, 0. These don't even react. Let me find a good one. This one's reacting half as much as this one because it's smaller. These guys are 0.4 and 0.6. So the middle one, because it's taller, reacts more than the outer one. So we can use that alpha to even get kind of offsets and stuff like that. So that was 1 hour on the money, a tutorial walkthrough of how to use world position offsets to help bring your environment to life, make it more interactive. Some of my old coworkers used to call this making this a living, breathing world. And it's amazing how much it adds to it. I think if I was going beyond just things reacting to the player as the player goes by, of course the next fun one is making the grass destructible. We'll probably do that in the future as well because there's just nothing more fun than just wrecking stuff while you're running around the level. But I thought this would be a cool way to show you what I was doing to create a tie-in to the living, breathing world in a way that's way more performant, doesn't use overlaps, doesn't use all these kinds of things, at least so far in all of my testing. And at the very least, it taught me an insane amount about materials, creative problem solving, all those kinds of things. So that's what I got. Does anybody have any questions?
I was gonna ask if you did you try doing multiplying a sine wave by a negative exponent instead of doing the atlas lookup to get your amplitude?
I did not, but wouldn't that would still have a problem in the sense that the sine wave is moving in time?
You still use your position as the argument instead of time, and you just multiply the sine wave by an exponent. The thing you drew, can you bring up that
Yeah.
atlas drawing? So that thing you drew is a thing that shows up in physics classes called a damped harmonic oscillator.
Yeah.
And so if you think about like a shock absorber on a car,
Yep.
it's like a spring that gets its oscillation gets squished over time.
Yeah, so a better one is
time,
this one.
Time could be distance from the player still.
Yeah, except, and actually that would work if, hold on, let's actually just double check. Like I said, there's always there's more than one way to skin this cat. But I believe this input, what is this input? Oh, it's time. Yeah, we could actually do that. Let's do this. Okay, you know what? Let's do a quick test. Let's take this.
Another way of doing it, but let's see this one first.
Okay, so if we push it, rather than plugging time into our sine wave, if we plug our distance, say again.
It's you on camera.
Oh yeah.
Which is great, but also
no, but also not helpful. Okay. So if we just put in rather than plugging the distance into, rather than plugging time in, just for reference, what they're talking about here is rather than plugging time in here, if we plug distance in here, we can get the sine wave. Okay. Now, what this will do is theoretically, this will still potentially work, but everything will move exactly as it was, right? And then the math, and this is where math geniuses come up, and we have one in our midst. So what we could do here in order to get what is being discussed here is if we multiply this by a negative exponent, I think it was, right?
Yeah.
So I think that's a power in the material world. So the base would be this, and the power would be negative, what, like -2?
No, it needs to be the negative of the replacement for time, so the distance from the object. So
I see.
The form is
yes.
e to the minus x times sine x.
So
or
it would be
usually
this.
it's cosine because you want to value it 0.
-2, plug this in, and that's going to create the damping, is what you're saying.
No, the input to exponent needs to be minus whatever, 2 is fine, multiplied by the distance from the player.
Then what's the base value? Time still?
No, it can be whatever you want. That's the amplitude.
Oh, okay. So
Or
we would
is
just
this
fill.
is this actually a power or is it an exponent? So
This
normally
is a.
I
This
don't know
is
what
an
power
exponent.
actually is. Sure,
Returns
10.
the base value raised to the power of the exponent.
Yeah,
base value.
10's fine. It might be, you might have to make it smaller, but so
Yes.
yeah, and then feet take that that thing right there, that pin, and multiply that by -1, and pass it into the exponent.
And pass it into this one.
So that the
times,
output
I
of that
see,
thing,
so
that right there,
negative-
yep, multiply -1.
-1.
Yep,
Not
and then
11.
pass that.
Pass that into the exponent.
Yeah.
And then this goes away. And this plugs in straight like that.
No, multiply those. So multiply power by sine.
Like this.
Yep.
And then
And then
this
the
plugs
input,
in here.
the input to the sine needs to be the output from the divide thing. Yep, that thing. Yes.
Okay. Let's see what it looks like.
Yeah. You may need coefficients and like different numbers, but
Yeah, but yeah, I mean the overall goal is.
yeah.
That also works. Okay, it's move. Hold on a second though.
You have to go the other way though, doesn't it?
Hold on. I need to think.
So
Okay, so
first
if,
thing, replace sine with cosine. Because in your
yeah,
lookup,
I understand.
you had an
Cosine starts at
amplitude
1.
0.
Yeah. So cosine. So if we go cosine instead, cosine.
Yeah.
Okay.
And then the other thing would be that you would want some control values like the amplitude and the period and stuff like that.
Yeah.
But
That's fine though. But let's just. This is all just in the vein of learning and
yeah.
trying things different ways.
Looks
Okay,
like
but
this
it's
goes the wrong
opposite.
direction.
So we just need to multiply by -1. That would do it. And we're gonna multiply by -3 just to increase the size of it a little bit.
Whoa.
What?
Okay.
That's trippy.
So let's try -2. Okay, it's moving the opposite direction still. So we're okay. This must not be the right place. Oh wait,
Yeah,
what's the
this is
subtract?
just the amplitude of the.
We don't need the
Ye-
subtract.
Oh yeah, maybe that.
We don't need the subtract. This is the size of it. Okay.
Yeah,
There we go. Much better. Cool. So that's actually really cool too. So that works. So basically, and this is totally in line with everything that we've been discussing. There are multiple ways to do this. This is really cool from a math way. I like that from a math standpoint. The one thing I do appreciate though, that I do like about having gone through this method, is that we have total control. I can sculpt the exact curve that I want for the fall off if I want to. I think my question would be, like, from an artist standpoint, this is pretty easy to figure out. I think what I'm gonna keep this though. Let's go ahead and do this. Let's take this and let's take this and comment this. Okay, we don't need this multiply. This is going to be, the math way. Maths, okay? And then what we're going to do is, let's do one more test while we're here, just in this, in the vein of the learnings. We're going to connect in the R value back into our multiply, but we're not going to do the subtract this time. What we're going to do is we're going to see and make sure that the negative values, negative blacks work. So to do that, let's just take all of these and shift this down to be 0, right? So it starts at 1, goes towards -1, etc. This should still work because I believe just like you can have positive values in RGB, you can also have negative values, and then we don't need to do the subtract. So let's save that. That's there. Let's go back to our material. Let's apply that. Theoretically, we should still have we do. Now, one thing I will say is, so that's cool. And the great thing about that is that I can now come in here, and if I, as an artist, want this value to start off bigger, I can just amp this. And I can have a quick little fall off. And by doing that, when I come in, the initial hit that's going to be felt here as we run by these objects, it's going to be a lot more, right? It's a lot more abrupt. And I can sculpt that really well. That said, though, one thing that's nice about the math approach is there's an issue here where if I want to slow this effect down or speed it up, this divide gets really funky. Okay? If I wanted to, and technically for the math approach, I should probably connect in from here.
Yeah, and you should have that when you're multiplying by -1 in the exponent, that should be -1 times a variable, so that you can change how aggressively the sine wave gets damped out.
Yeah, exactly. And that is exactly what I was just about to say. So the cool thing about the math approach is basically this divide takes this curve, and basically you only get, at 0.5 seconds, you're actually going to sample at 1/4 of a second, for example. But there's a world where you don't get to the end. The cool thing about the math approach is you're going to get to the end, right? Because the dampening is going to work over the distance. So just like with anything else, like multiple ways to do it. That's awesome. Thank you for kicking in that stuff. I don't know if I would have ever come up with the maths version of that, which is hilarious because I had to take that horrific Fourier transforms class. It's all about the signal theory and curves, and I've managed to block it all out of my mind. So that's really cool. Thanks for sharing that. Yeah. Anything else? Any other questions for the stream, y'all?
Rusty keeps jumping in and out. I don't know if he... Are you there, Rusty?
Rage quit.
Maybe. I had one other thing from your stream. You mentioned the position of the player being a 4 vector.
Yes.
That's because when you're doing transformations in the in shaders for positions, to be able to do translations and perspective projection, you need a 4 vector. So when you're multiplying the position of something by a 4x4 matrix to do rotations, translations, scaling, and stuff, you need a 4 vector.
Yeah, and the thing that was that makes total sense. The thing that was interesting to me was it's automatically doing that. I didn't realize it was doing that because I'm passing in a 3 vector to the material parameter collection. So it's converting that and probably appending an extra value on that.
Yeah.
So, and I didn't realize that that's what was happening. I guess I'm used to, I pass in a 3 vector, I get a 3 vector out, especially in materials versus, if I click, yeah. So in materials, just because the way my brain works, I'm used to being in here and being like, oh, I need a 3 vector. I press the number 3 and left click.
Yeah.
And I get a color, RGB. But if I specifically want the one you're talking about, if I press 4 vector, then I get the 4 vector So I was just surprised that the material parameter collection automatically was returning back a 4 vector, even though I passed in a 3 vector in the pawn component. So,
Yeah.
but if there aren't any more questions for the stream, we'll go ahead and call it a wrap up. We'll give Rusty one more chance. We'll hang out here just in case Rusty comes back and has something else. For everybody else, as always, thank you for supporting the channel. Thank you for helping spread the word. If you haven't played the game, it's available. You can download it. Their links are down in the comments down below, in the video description, to download the game, play the latest version of the build that we've got going. All of your feedback is very much appreciated. This was a lot of fun to set up. It was a cool little problem to try to figure out a way to do this without using time and overlaps on every single thing. And I'm actually really happy with the way it turned out. So hopefully this little tutorial-like dev stream was helpful for you all. As always, I hope you all have an amazing rest of your day, week, and weekend. Take it easy.